So this is the second part of graphing functions. And what we're going to talk about here is parent functions. And it's kind of weird that they're called parent functions, but what it means is that all functions, most functions that we deal with, and we're just going to deal with 6 parent functions. There are more, but we're going to do the most familiar and most popular, or used the most often, parent functions. And what it really means is that every function off of these 6 are just offsprings. And if you think about it, do you look like your mom or dad? Yeah, I do. Okay. My hands, you can even see my hands look just like my dad's. Our thumbs are exactly. So I am an offspring. So I have something in common with my dad. That's what these functions are dealing with. That's the reason they're called parent functions. So we have 6 that we're going to look at. These are the most common ones. This is a graph with a straight line. Examples of equations with this type. Y is equal to x. Y equals 3x. Y equals 7x minus 2. Y equals 2/3 x minus 8. Okay? Those are all these are examples, just examples. We could go on and on and on and on. What do all of these equations have in common? The highest power is 1. These are called linear equations. Now, if you were in class, I would pause and let you write it down. You have the video in front of you. If you need to, pause it and write it down. Okay? So these are linear equations. Look at the root word, line. Linear equations. So that's one of the things you're going to use to remember this by. Linear equations are a line. Look at that root word right there. Right there, line. So it tells you the answer. And that's one of the things you're going to do on the test is you have to match up. One of my recommendations, if you can, is to make flashcards of these. And they don't have to be perfect, but the shape, you can get the idea from it. Okay, so these are linear equations. The second one is a U-shape. It is called it looks like it should be pronounced parabola, but it's called a parabola. Parabola. Okay, parabola is how you pronounce that. Examples of equations with this type. Y equals x squared. This is the parent function. That is the parent function. Okay, so this is the parent function, y equals x. Here's the parent function here, y equals x squared. So y equals x squared. This one is y is equal to, I won't even get into that one right now, 3x squared plus 5 as a parabola. Okay, y is equal to x squared minus 5. Y is equal to 3x squared plus 4x minus 7. These are all going to be parabolas. They're all going to be a U-shape. What do they all have in common? Their highest power is 2. It's called a quadratic. Now it seems like quadratic, if I'm looking at root words, quadratic should be a power of 4. It's not. That's a quartic. Think quarters. This is a quadratic. Quadratic is a power of 2. Okay, a quadratic is a power of 2. That one's not as intuitive as to where that one comes from. Here's how I remember it. Parabola is the way I have to say it to spell it. Look at that. Bowl. It looks like a bowl. Okay, so a parabola is a U shape. It's a quadratic. The third type, graphs with a curve that switches directions. I'll tell you more about that. Y equals x cubed. That is the parent function. Y equals x cubed minus 7. Y equals 3x cubed minus 8. Y equals x cubed plus 2, x cubed plus 2x squared minus 9. Oh, plus 9, just for the heck of it. What do all of these have in common? Highest power is 3. Now, and these are called cubics. This is a cubic function. Okay, its highest power is 3, so cubic. And it's kind of like it's a sideways S. Let me show you some other cubics so that you can see what's happening. If I did a cubic with a few more things in it, as far as the equation would look like this. See how it's kind of a sideways S? This one comes through and it lays flat and goes on through. Okay, so it has 2 bumps. If we were to stretch it out, that's hard to see on that one. But it's kind of a sideways S. This is a cubic. Okay? Good. Again, pause whenever you need to. You have that power. This is a graph that is a V shape. Examples of these. Y is equal to the absolute value of x. Parent function. Y equals absolute value of x plus 1. Y equals 2 times the absolute value of x minus 5. Absolute value sign, sorry. Okay? So you could kind of guess. What do all of these have in common? Yeah, not a hard one to figure out. They're all absolute values. Okay? Have absolute value sign symbols. And absolute value symbols are just the straight lines and the stuff in between. And remember, absolute value. So when I plug it in, it's kind of like it's a magic little thing right here. Anything I plug in, as long as there's not a negative out in front, anything I plug in is going to always give me a positive back out. That's the absolute value function. It always gives me a positive back out. So these are called absolute value functions. And you might have already figured out a way to remember these. I kind of emphasized it there. Absolute value are going to have a V shape. Absolute value are going to have a V shape. Always, always, always. Absolute value are going to have a V shape. Now, sometimes that V shape is inverted, so you can also have a function that looks like this. This is also an absolute value function. It would just have a negative out in front. Okay? This one would be something like y is equal to the negative absolute value of x minus 2 plus 3. Okay? Don't worry about how I know all that other stuff, but it is an absolute value that goes down. It opens down. So absolute value opens up. Now this next one is a graph with a half of a U shape. It just goes over like this. Examples of these functions would be, parent function, y is equal to the square root of x. There's your parent function. That is your parent function. Okay? But keep watching. Y is equal to the square root of x minus 3. Y is equal to the square root of x plus 7. Y is equal to the square root of x plus 9. Okay, notice the 9 is not underneath the square root. These are all, what do they have in common? They have a radical sign. Okay, they all have a radical sign, a radical symbol. These are called, you can probably guess it, square roots. Now on these, how do I remember these? Well, okay, this is a weird way. It's a parabola on its side, but only half of it. So the opposite of a squared is a square root. If I would continue this on, see how I would get a parabola on its side? Okay? So I'm only getting half of a parabola, and the opposite operation of a squared is a square root. So that's how I remember that one. Not too helpful, probably. Graphs with a curve that grows wider. Okay? This is examples of these. Y equals 2 to the x. Y equals 3 to the x. Y equals 2 to the x plus 4. Okay? You're getting the idea. Y equals, well, this graph is not, but the parent function for this one changes depending on what this number is. So it's y equals b to the x. That is the parent function, and we have to do it that way because our b can change it. It depends on where that is. So I can even have a 1/2 to the x. Not exactly. That would go a different direction, but technically that is that same one. Notice with all of these, where is that variable? It's in the exponent. Exponent is the variable. So guess what these are called? Yeah, exponent, exponential. Okay? And what happens with exponential, and unfortunately that's what's happening with COVID, or happening right now with COVID, is that it goes exponential. It goes up very quickly. It's not just this night. It goes up very quickly once one person has it. It's because it multiplies so quickly. It goes up exponentially. So you've probably heard that term, that something goes up exponentially. This is what the graph looks like. It goes up very quickly. It's not just this nice flat little thing. It goes up wham. When we talk about things that multiply in science class, cells that multiply very quickly, that's what an exponential function is. Okay, now your homework. Why did I not bring out the homework paper? Well, your homework is the next page after. Let me pause and pull that out for a second. So this is what your homework looks like, and what it wants you to do is it wants you to match them up. So I would suggest you match them up and then name the family that it's from. Name the family is what it's called. So what is its parent function? So you're going to name the family, you're going to match up which ones work with what, and then you're going to name the family. Here, you're going to take the equation and you're going to put it into the box. So which one of these goes into these? So it's just practice so you know what goes where. Okay, write the equation and where it goes. So for instance, I'll do the first one. Y equals x plus 5 cubed minus 7. So that is a cubic. So I write down y is equal to x plus 5 cubed minus 7. That's what you're doing there. Okay, put it in its family box. Put it in its parent function. On the back, determine whether or not the following situations would best be represented as a linear, an exponential, or a quadratic. Okay, a linear, an exponential, or a quadratic. And what you're going to be doing there is just, does it go up quickly? Or how does that work? That was a different homework paper than I thought it was going to be. Anyway, take a guess on those. It's just good for your brain to be thinking through that. Use a table to sketch. We give you values, but what you always want to do is when you get to one, kind of make a little sketch over to the side as to what that would look like. Okay, that's your homework, but I want to practice a couple more problems. I want you to put down the parent functions for all of these. The parent function for linear is y is equal to x. And the reason you do that is because this is what you're going to base your graphs off. We'll get into this later on. And if in doubt, pick like -2, -1, 0, 1. Oh, no, -2, -1. Sorry, I didn't know there was 5 places there. -1, 0, 1, and 2. And draw that parent function out. That's going to be really helpful if you do that. Find the y's. Quadratic, y is equal to x squared. Here again, you're going to use -2, -1, 0, 1, and 2. Plot that. You're going to refer to that. These are good notes to have so that you can see what the parent functions are. This will come back again. This whole unit will come back again. Cubics, again, -2, -1, 0, 1, and 2. But that's the parent function, y equals x cubed. And get an idea of what that looks like. Absolute value, y is equal to the absolute value of x. Find out what those look like. Okay, graph those. Have a graph of that parent function. Square roots. On this one, we go a little bit differently. Because of the square root function, its domain is restricted. Oh, sorry, just x. That's the parent function. I got a little ahead of myself. Y equals the square root of x. And what you want to realize is, remember, you can't have a negative, so you're going to actually start at 1. Now, I could, sorry, at 0, I wrote 0. Now, you could just plug in whatever, but you're going to want to put in perfect squares there. So plug in 1. That's a perfect square. 2 squared is 4. 3 squared is 9. Okay, see what you're doing there? 9 squared and then 16. You're going to see that's going to probably be off the chart. I think we did that one, or one like that, the other day. Okay, an exponential, y equals, and we're going to choose for your exponential function, we're probably going to choose 2. This is the most common. So this is a parent function. Again, exponentials, their parent functions change depending on what the base is. And on this, go ahead and go -2, -1, 0, 1, and 2. And look at what that domain and range is. Okay, so I want you to do those on your own because that's a good practice. Will I know if you did them? No. But man, you're going to know these way better when it comes to the test. So that's parent functions. They're cool things. We're going to do more with them later on this year. And then boy in Algebra 2, you'll see them again. You'll know them well. Thank you. If you have questions, you know where we are.